Zero. Hello friends, welcome to our channel. Today I will discuss another topic, that is a reverse Polish notation with a stack operation. Okay, reverse Polish notation with a stack operation. Okay, before that, before this topic, I have already explained different notations for arithmetic operation, that is a infix notation, prefix notation, postfix notations. Okay, so today I will discuss regarding on reverse Polish notation. Reverse Polish notation is a very simple notation. Actually the name of the postfix notation is known as reverse Polish notation, or sometimes some short form also we can write like a RPN, reverse Polish notation, RPN. Okay. And some when we go through any kind of arithmetic expression, then we use sometimes that is stack organization, and stack organization is very effective for evaluating arithmetic expressions. And some mathematical method of writing arithmetic expressions imposes difficulties when evaluated by computer normally, because different expression can be evaluated by computer systems. Okay, so sometimes it is difficult to evaluate, and the common arithmetic operations or expressions are written in infix notation with each operator in between, that is operands. Normally we know that, we have already discussed that, but whenever we go through infix notations, very simple way only, that is defined the infix notation. For example, we just consider this expression, that is a simple expression, this particular a star b plus b c star d means a multiply b plus c multiplied by d. Okay, simple expression we will consider. If we go through that expression, then what happens? Star denoting normally, all of you know that, that is multiplication. Star means multiplications and placed between two operands a and b and c and d. Okay, after that plus between two operands. I have already mentioned that in between two product. Okay, one part is here, you see very simple way it is mentioned, that is a into b plus b c into d. That means two plus operator is there in between two product. This is one product, this is the another product. Okay, like this. And evaluate this arithmetic expression, it is necessary to compute the product a and b. First one a and b, then another product is c and d, then sum of two products. It is a very simple way. First product a and b, and second product c and d, and then the sum of that two products. And if we go through that particular expression, then we see that that expression initially we consider as a infix notation. Okay, and it is necessary to scan back and forth along to the expression to determine next operation. Suppose one expression is completed, then go through another expression. It is a very simple way. But think that if we go through this postfix notation, first of all we see that what are the number of notations used for any kind of arithmetic expression, and how to define that is reverse Polish notation. Since our aim or our topic is reverse Polish notation, then we go through reverse Polish notation, which is defined through, that is a postfix notation. That means postfix notation, other name is a reverse Polish notation. Very simple way, that is I will tell you, because there is one another name, Polish reverse Polish name, that one scientist name is actually Polish. For that reason it is mentioned, that is a reverse Polish notation. And a very simple way we have already discussed, that is again once again we just see that how to demonstrate different expression with a different notation. Suppose we go through simple example, we will take, that is a plus b, and if we go through a plus b, then what happens? If we go through, that is infix notation, that is a plus b, that is direct that expression we can write. If we go through prefix, I told that is, if we go through prefix, first operator will come, then what happens? That is next is operand, that means plus ab. If we go through this particular expression a plus b, if we go through prefix, then first operator, then is operand. So in this way you can write. So here a plus ab is a prefix or Polish notation. Actually it is a Polish notation. If prefix we can tell as a Polish notation, and if we go through postfix, then a reverse Polish notation. Okay, and if there is a operator in between a and b, then we can go through infix. And reverse Polish notation, a plus b, a b plus. Okay, postfix. So operator is after operand. This is postfix. So in this way one is infix, next is policy notation or prefix, another is reverse policy notation or postfix. Three notation we can use for any kind of a arithmetic expression. Same thing we will see if we go through another expression, then how it will define and how it is evaluated. Okay. If we go through reverse policy, since our topic is reverse policy notation, then it is a very simple way in the form of suitable stack manipulation. And go through, this is the very simple expression. If we go through reverse policy, very simple. First of all, this product we write A multiplication B and a plus C multiplication with D. This part we do that A B star. Then another part C T star. In between that two product, plus is there. So plus is right hand side, since it is a reverse policy notation. Okay, very simple way. We have already discussed that part. For the postfix notation. So postfix notation is a reverse policy notation. In this way we can define. And this is the basic concept. And another is whenever evaluate those particular postfix notation or reverse policy notation, then what happens? We scan the expression from left to right, because all expression is scanned from left to right and then evaluated through operations. You see very simply, this is scanned from left to right here. Left to right we have to scan. That is first is operand, next is operand. Whenever operator will come, then it will evaluate. Okay. Similarly, C is coming first, next D is coming. Whenever multiplication will come, then this operation will start. Okay, this is the basic concept. So the scan expression from left to right normally for any kind of operations. When an operator is reached, when a scan from left to right, then first operand, next is operator. Whenever operator is reached, then perform the operation. Okay, perform the operation. The two operands found, with the two operand found from left side to left side of the operator. For example, suppose you write this one AB. Okay, AB. Suppose AB star. That means first A and B. Whenever operator this star is coming, then it will start the operation A into B. Okay, like this the scan and operation do in this way. Remove the two operands. Okay, remove the two operands. After completion this one, remove the two operands. When that operands we will have to remove, and the operator, both operator and operand we have to remove, and replace them by the number of obtained from the result of the operation. Whenever this result will get, thus what is the result, that part only keep it in next. Okay, but you remove that, because this operation, after completion of this operation, just keep the result. What is the result? Suppose R1 result, for example R1 result. Okay, and keep in R1 result, and after that another operation is there. Okay, and continue the scan from left to right, and another operation will continue. So another operation, like suppose we go through another is C D star, for example. It is a R2, result is R2, for example. Okay, that means here R1 R2. Okay, then plus, because R1 is this one. Okay, R1 is this one, R2 is this one, and after that plus. Okay, so here now R1 plus R2. So in this way we can there is evaluated the different operations. Okay, take an example, very simple way. Take an example, that is a following example we can take to clarify this procedure. Let us consider. So one simple arithmetic expression we will consider: 3 into 4 plus 5 into 6. Okay, for the reverse policy we can write very simple way. 3 into, here is 3 into 4, 5 into 6. So first part is what you write: 3, next operand is 4, next is star. First part is over. Second part is 5 into 6. So 5, 6 and a star. This second part is over. So in between that plus operator is there. So plus operator is there. Okay. So in this way we have to calculate. Okay. Or we have to evaluate or make in this notation postfix notation, or that is reverse policy notation. And whenever you evaluate, first you evaluate this one. Okay, how to use, if you go through scientific calculator or any other calculation, then evaluate this one. 3 4, first come to 3 4, 3 4 and here a multiplication. So suppose the result is R1. Okay. Result is R1. Similarly, multiplication by 5 into 5 6 and in here also multiplication, it is R2. Okay. Then what happens? R1 R2, that means here plus is after that, that means R1 R2, here is plus. What are the result? R1 R2, R2 is here is 12, we can write it 12. So 12, second one is 30. Okay, 12, next is 30, next is plus. Then what happens? We write like 42. Okay, we got the result, that is 42. So scan from left to right, whenever operator will come, then what happens? It will that is evaluate immediately and store the data, the result data. Suppose R1, here is another operator, that is operation 5 into 6 and store the data, that is R2. Again the concept is like this: R1 R2 plus. R1 already there 12 and R2 is 30 and plus is there, so total is 42. So this kind of result we can get it. Okay, very simple way I will show this kind of result. Okay, so this is the basic concept whenever go through this reverse policy notation. Okay, so I will discuss this kind of operation using stack. Then very easy way I have to I will discuss that how the stack use through this particular operation. Okay, and if we go through stack, then very simple way, if we go through stack, what happens? Another way we can, that is evaluate. Very simple way, that is scan from left to right and store that data. Here I will show you. Okay, very simple way. If you use the that is stack operation. Here expression, you see, very simple way. What is the expression? 3, here is 4 star, here is 5 6 star and a plus. This expression is given because according to this the expression is given here. Very simple: 3 into 4 plus 5 into 6. This expression convert to reverse policy notation, reverse policy notation in this way. Okay, so how it is defined? Very simple way. So now we see this particular expression we have to evaluate it through stack. Okay, so through stack operation, this is evaluated through stack operation. You can write through stack operation. Okay, so now we will start this stack operation, how it will evaluate. Now see, from scan this expression, scan from left to right. First one, what happens? That is 3. Since it is a stack operation, we have to check that stack contains the number of items and it is identified, that is identified by that is pointers. Okay, identified by pointers, stack pointer. We have already discussed stack operations, different operations. And here suppose SP stack pointer identify here bottom level and scan from this particular expression, store the data 3 into here. So stack pointer contains 3. Again another data is 4. Whenever SP, here SP is there at position, suppose here is 0 1 2 3 for example, then SP is that is increasing at one position. Okay, 1 2 3 0 1 2 3 0 1 2 3 0 1 2 3 0 1 2 3 0 1 2 3. Okay, so you see whenever SP shift to position 1, then what happens? This 4 the operand 4 need to insert into the stack. Okay, so now 3 and 4 here, whenever star means one operator is coming, then what happens? When an operator is coming, then it will start the operation, because it when you found the operator, then it will operate on the top of the 2 operand. Okay, that means here 3 whenever a star is come, then automatically operation will start, and that operation, so let us the operation particular 3 into 4 store in one location, R1, so result is R1 store in top. So whenever 4, 3 and 4 available in stack, whenever a star is coming, multiplication is coming, then it will operate. And the operator means is result of this operation store in top of the again stack. Okay. So 3 into 4, that is 12. 12 is stored in again, because that is automatically stack is come to 0 position, because after multiplication the value is that is 12, this 12 and store in 0 position. Okay. Next another is next 5. 0 position, how, what is the 0 position? 0 position is 12, here is 12. Okay. So next another, it will scan from this side, scan from left to right, again 5 is coming, 5 is stored, that is a stack pointer shift to another position, that position is that is 1, 5 is stored because 5 is entered into the stack. Again what happens, again stack pointer shift to next position, that is 2, and 6 is coming. Next whenever a star is coming, this multiplication operator is coming, then it will operate this top 2 items, these 2 items will be operated. What is the operation? 5 into 6, 5 into 6 means 30. Okay. 5 into 6 means 30. So on the top of that 2 position of stack, then multiply 5 into 6 according to this particular operation. So 5 into 6 is 30. And now we see that 0 position and this 30 store in here. Okay, 1 position, because after multiplication result is stored in top of the stack. So 0 position initially it was 12, and first position it was that is 30. Next another operator also there, that is a plus operator. Then what happens, again add our 2 top items, that is 12 and 30. Again whenever add 12 and 30, so result will be again 42. You see, result will be 42. This 42 store in what? 0 position, because 30 plus 12 is 42, so store in 0 position. In this way you can operate or different operation we can consider for stack operation of any kind of arithmetic expression. First convert to reverse policy notation, and it scan from left to right. Very simple, scan from left to right. Okay. When star or when any operator will come, they will start the operation of the top of 2 items from the stack. Okay, top of the 2 items from the stack. That is important, because which operation or which operand they will take and evaluate, that main important is top of 2 operand need to operate. Okay, top of 2 operands need to operate. Okay, based on that what kind of operation is there, maybe addition, maybe multiplication, what kind of operation is required, based on that they will operate. Doesn't matter, because here is multiplication, so multiplication is required. Here is plus, so plus is required. So based on that, so it will operate on the top of the 2 operand. Okay, after that result it is stored in next, that is below that position of the stack. It will depend on that, because here you see position of the stack pointer, here when after operation it will come to 0. Here is 1, but it will automatically come to 0. Depend on that situation at what position stack pointer you will be identified. Okay, so this is the basic concept we discuss. This stack pointer and use the stack operation for this reverse policy notation, or that is we can tell that is so reverse policy notation with stack operation is completed. So any kind of operation we can take for this particular operation or reverse Polish notation, take any kind of arithmetic operation with the stack operation. So stack operation is very easy. Once you understand this particular notation and stack operation, then any kind of arithmetic expression suppose given, we can that is operated through this stack operation. Okay, so I hope all of you understand this particular topic, and this is important. It is a problematic topic. So I hope all of you understand this topic. Thank you very much. Thanks to all to watch my videos. Please subscribe my channel, and if you want to comment, then you can comment me. Okay, thanks to all.